All right, ready to dive into something pretty wild. Microreactors.
Oh, yeah.
I mean, we've all heard of nuclear power, those giant plants, right?
Yeah.
But what if we could, like, shrink it
Mm.
way down?
Mm-hmm.
That's microreactors.
That's the idea, yeah. Super compact, all self-contained.
So, like, the power of a plant, but it fits, what, like in a shipping container?
Something like that, yeah.
That's kind of crazy to think about.
Yeah.
But why is smaller so much better? In this case, I mean.
Tons of reasons, honestly. Like, first off, way cheaper to make, way faster, too.
Okay, yeah, that makes sense.
If you think about, like, computers, right? They
Yeah.
used to be whole rooms. Now they're in our pockets.
Oh, that's a good point, yeah.
Yeah.
So we're talking tiny nukes, but
Yeah.
how do they actually, like, work?
Mm.
I saw this thing about playing billiards with atoms.
Yeah, that's a pretty good analogy.
Right.
It gets at the core of it. Fission, splitting atoms, releases heat, boom, power.
Okay.
But what's different with microreactors is the fuel itself.
Oh, so it's not the same stuff as the big plants.
Nope. Often they use something called triso fuel. So picture it like tiny, tiny bits of fuel, but each one's coated in like layers of ceramic, super tough.
Sounds like a tricky heat, yeah,
High-tech, tiny, armored fuel pellets.
basically. And that's part of why they can be so small and portable in the first place.
Speaking of which, there's this company, Radiant. They're doing some cool stuff with this, like replacing those huge diesel generators, the noisy ones.
Right. Their whole approach is interesting. They're starting small, proving the tech works, then going big.
Kind of like a proof of concept before you build the whole skyscraper.
Exactly.
Smart. So generators are one thing, but what else could you use this for?
Oh, man, so much. Like, imagine remote areas, right? Disaster relief, military bases, all running on this clean energy from a box, basically.
Wow. So places that never had reliable power before, this could be huge.
Absolutely. And way better than, like, hauling in diesel all the time. Right. Okay, but gotta ask the big
Good point.
question. Safety, right? Everyone thinks nuclear and, yeah.
Yeah, no, I get it. But that's why the design is so focused on safety. It's baked in from the start.
So, like, that triso fuel helps.
Big time. Because it's all locked up tight, even if things go really wrong, it's unlikely to release anything bad.
Okay, so the fuel's safe, but the whole reactor itself.
Layers of safety features, like passive systems, meaning even if the power goes out or something fails, it shuts down on its own.
So it's designed to fail. Safe.
Exactly. Plus, the cooling, a lot of it's just natural physics, convection, so even with no power, it still works.
Wow. Okay, so a lot of thoughts gone into that side of it. But where are we at, like, actually seeing these things out in the world? Is this all just, like, on paper still?
Oh, no. Companies like Radiant, they're testing right now. Like live fuel tests, they're aiming for in a little over a year.
What's a live fuel test?
Basically, that's when they put in the real nuclear fuel, run it at low power, make sure everything performs perfectly, all the safety checks out.
So, like, a working prototype, almost?
Pretty much. They're making good progress, meaning we could see commercially available microreactors sooner than we think.
That's wild. But before we get too ahead of ourselves, I think it's important to, like, compare, right, these to the old school plants.
Absolutely, yeah. I mean, the biggest difference right off the bat is size.
Right, those things are huge.
Massive. We're talking thousands of megawatts, enough to power whole cities.
Exactly, yeah. So microreactors are more for, what, like towns or big factories?
More like that, yeah. Less than 10 megawatts, typically. And because they're smaller, they can be put in lots more places and faster, too.
So if you need clean energy, quick and flexible, this is the way to go.
That's the thinking, yeah. Especially if you need something reliable and totally independent.
Okay, this is pretty amazing stuff.
Okay.
But it does make you wonder, like, what are the challenges? What are the risks we need to be thinking about?
Oh, for sure. There are always challenges with new tech. One of the big ones people talk about is proliferation. Basically, could this stuff be misused,
Yeah, that's a scary thought.
Absolutely. So we need really strong safeguards internationally to make sure that doesn't happen.
So it's not just about building them safe. It's also about making sure they don't fall into the wrong hands.
Exactly. And then there's public perception, right? Even with all the safety stuff, some people just hear nuclear and get nervous.
Yeah, that's understandable. I mean, there's been accidents in the past.
Right. So being transparent, educating people, open dialogue, all that's super important to build trust.
So we need to talk about the risks, be honest about them, but also about all the good these things could do.
Exactly. And we can't forget the environment either. Even though microreactors produce way less waste than the big plants, there's still some waste. We got to be responsible about that.
Right. Even if it's cleaner than fossil fuels, that's still something to figure out.
Yep. Researchers, policymakers are working on that, how to minimize it, how to store it safely long term.
So a lot of moving parts, as they say.
Definitely. But the potential upside is so huge, it's got to be worth it. This could be a total game changer.
Oh, absolutely. A game changer. Imagine, like, clean, reliable power everywhere, even the most remote places.
Yeah, that'd be incredible, right? Especially those places that never had consistent power before. We've been talking about Radiant and how they're focused on replacing generators, but what else could you use these microreactors for?
Oh, man, tons of stuff. Like heavy industries, the ones that need a lot of heat, a lot of energy.
Oh, like manufacturing or chemical plants, things like that?
Exactly, yeah.
Yeah.
Right now, they're mostly using fossil fuels, so this would be a much cleaner way to do it.
So we're talking about decarbonizing those big industries. That's a huge step.
Absolutely. And then there's, like, disaster relief, right? You could bring in one of these units to a place that just got hit by a hurricane or an earthquake.
Yeah.
Get power back up and running right away. Wow. Yeah. Instead of having to wait for the grid to come back online or trucking in generators.
Right, exactly. And sometimes it could even help prevent disasters.
Really? How?
Well, think about desalination plants, the ones that turn seawater into drinking water.
Oh, right.
So you could power those with a microreactor, provide clean water to places that are dealing with droughts.
So it's not just energy security, it's water security too.
Exactly. And we're just scratching the surface here. I mean, some people are even talking about using them to power spacecraft.
Whoa, seriously? For like deep space missions?
Yeah, that's the idea. The possibilities are really endless. But of course, there are going to be challenges too, like we've touched on safety, proliferation. But what else? What are the other big hurdles? Well, regulations are a big one.
Ah, right, of course.
Every country has their own rules about nuclear power, and getting approval can take a long time. It's complicated.
So it's not just about building a good product. It's also about jumping through all the hoops, making sure everyone's comfortable with it.
Exactly. Public perception, like we talked about, is a huge part of that.
Yeah, and like you said, open communication, being honest about the risks, but also all the potential benefits.
Right. And then there's the economic side of things, too.
Oh, yeah, of course.
Like, these things have the potential to be really cost-effective in the long run, but up front, the investment can be pretty big. So governments and investors need to be on board.
So it's kind of like a chicken-egg thing. You need the investment to make it happen, but people want to see that it works before they invest.
Yeah, that's the challenge with any new technology, pretty much. But I'm optimistic. I think the potential here is so big that we'll see more and more investment coming in.
Yeah, I mean, it seems like there's a lot of excitement around this technology right now.
Absolutely. More companies are getting into it. Research is moving forward. It's a really exciting time to be watching this space.
It feels like we're on the edge of something big, a real shift in how we think about energy.
Yeah, I think so too. It has the potential to change everything. How we generate power, how we use it, how we live our lives. It's about cleaner energy, more resilience, and a more sustainable way forward.
But it's not just about the technology itself, right? It's about how we use it, the choices we make as a society.
That's exactly right. We have to be smart about this. Think about the ethical implications, like what happens to the people working in the fossil fuel industry.
Right, we don't want to leave anyone behind.
Exactly. And we have to make sure that everyone has access to this new energy, that it's fair, it's equitable.
So it's about looking at the whole picture,
Yeah.
energy policy, social impact, the environment.
Absolutely. It's a complex challenge, but I think we can figure it out. If we work together, keep innovating, and really focus on building a better world.
Yeah, it's a challenge worth taking on for sure.
Definitely. And I think microreactors have the potential to be a key part of that solution. Imagine a future where clean energy is available to everyone, where we can power our lives without harming the planet.
That's a vision worth fighting for, I think. Totally. And it's not just about, like, swapping out what we already have, right? This could be whole new things become possible.
Yeah, that's what's so cool. It's not just a little better. It's like totally different thinking about energy and.
Okay, so let's, like, imagine if these things take off, like solar panels did, what does the world even look like?
Well, I mean, first thing, way less carbon, right? All those industries we talked about, the tough ones to make electric, those could run on this.
So we're talking no more fossil fuels, pretty much.
Getting there, yeah. Cleaner air, healthier everything, the climate's more stable.
That's the dream right there.
Yeah.
But it's not just the planet, it's people, too. How do we live differently if this works out?
Think about developing countries, man. reliable power that they can afford where they never had it before. Education, healthcare, the whole economy changes.
That's like skipping ahead, like a shortcut to a better future.
Exactly. And even here, in places that do have power, it makes things way more resilient.
Oh, wow, how so?
Think about, like, a city, right? If the grid goes down, storm, whatever, these things keep running. Hospitals, emergency stuff, it all stays on.
So it's like backup power, but for everything.
Basically, yeah. As we get more and more electric, that kind of safety net is going to be huge.
Okay, so far, this all sounds pretty amazing. But we got to be real. There's downsides too, right?
Oh, for sure. Nothing's perfect. Like we said, got to make sure this tech doesn't get misused. The proliferation thing, that's serious.
So like global rules, strong ones, that's got to be part of that.
Absolutely. And even just the economy shifting, that's going to be tough for some people.
Like the fossil fuel workers, all those jobs.
Right. We got to make sure everyone's taken care of, that this transition is fair.
So bottom line, are these things like the answer or just part of a much bigger thing we got to solve?
I say, a really important part. Clean energy, resilient, can be scaled up. That's a powerful combo.
But not easy, that's for sure.
Nope. Tech challenges, getting the rules right, people got to be on board. But I think it's worth it. It could be huge, you know?
It's been really fascinating learning about all this. Yeah. Feels like we're just scratching the surface, but I'm excited to see where it goes.
Me too. And everyone listening, stay curious. This is the future of energy we're talking about. It affects all of us.
That's a great point. It's not just for the scientists to figure out. We all got to be part of this.
Exactly. Ask questions, talk about it. Let's build a future where energy works for everyone.
Couldn't have said it better myself. Well, that's about it for our deep dive into the world of microreactors. Thanks for joining us.
My pleasure.